Okay, so one more thing for us to consider. There are three properties of exponents that we've been playing with, and they are definitely true for real numbers, right? But are they true for complex numbers? Is it true that if you have a complex number and you raise it, so if you have some complex number z to the w1, and you have some other complex number z to the w2, z is a complex number, w1 and w2 are complex numbers, is it true that this happens? I'm sorry, is it true that if z is complex, that happens? So there are things to think about there. Is that true? Um, is it true that if z is complex, that this is true? Is that true if we allow complex numbers into the mix? And is this true if we let complex numbers into the mix? Is that true? If complex numbers are allowed to enter the mix, are those true? Think for a bit. Play for a bit. See if those things are true. And then when you're done, unpause and we'll see together. Let's take them one at a time. Start at the very beginning, a very good place to start. Is that true? Well, what do we know? We know that z to the w1 is some real number to the w1 power times cosine of plus I times sine of, right? And then this is multiplied by r to the w2 cosine of w2 theta, right? Like that. 3, 4, 1, 2, 3, 4, right? So when we multiply these together, these real numbers multiply the way real numbers multiply, right? Because r is a real number, so these multiply the way real numbers multiply. And then we can do the multiplying of these things together, right? We can multiply these things together, no problem. We've got this. And surprise, surprise, it turns out exactly the way you imagined. Oh, there's a sign in there, right? I times the sine of that. It turns out to be exactly what you thought it was. It turns out complex numbers don't change this reality. Zimoff's theorem confirms for us that complex numbers do not change this reality. Well, what about this reality? Is that a reality? Consider the following. Is that true? Well, -1 to the third to the 1/2. Well, what's that? -1 to the third is -1 to the 1/2, that's I. So what is -1 to the 3/2 power? Well, -1 to the 3/2 power, we take the square root first and then cube, right? That's how this works. They don't match. And so -1 to the third to the 1/2 is not the same as -1 to the 3/2. Property 2 does not hold if complex numbers are in play. So, tiebreaker time. Does that hold or not? Does that hold or not? Let Z and P both be -1. Let W be a half. Watch what happens. What is this? Well, this is I times I, and that's -1, which is not the same as -1 times -1 to the 1/2. And so it is not true that this always holds if complex numbers come into the mix. Complex numbers makes things very, very interesting. But a lot of the things that we think are true are only true because the real numbers behave well. And that's just a thing to bear in mind when you're talking with teenagers. Most of the properties that, well, many of the properties that we enjoy are properties that are true because the real numbers behave nicely. The complex numbers behave nicely differently. Complex analysis reveals that to us. The complex numbers behave in a beautiful way, but it is not the way that real numbers behave. Okay, that's all I had for us in this lesson. I hope that things are well with you and that our paths cross again soon.